In this build along video, we're going to build the base platform for the SparkBot. After you've got FreeCAD open, begin by creating a new part in the part design workbench. Then in the tasks tab, we'll create a body, we'll create a sketch for it, and we'll create that sketch on the XY plane. Once we're into the Sketcher workbench, I'm going to zoom out a little bit so I can see the ends of the x-axis here. And I'm going to begin by creating a single line using the Create Line tool. And I'll create an arbitrarily length of line up at the top here. Right-click to clear my tool. And I'm going to make this line symmetric around the y-axis. So I'm going to left-click on the ends of this line segment. I'm going to left-click on the green y-axis, and I'm going to choose Constrain Symmetric. So this line segment is now symmetric around the y-axis, and I'm going to set the length of this line segment to 72 millimeters. Now I'm going to use the Poly tool, and I'm going to add some more to this line. So here's the Create Polyline tool, and I'm going to hover over the left side of that line segment. When it turns green, I'm going to left-click with my Polyline tool, and I'm going to go up a ways. I'm going to go to the left a ways, and at a slight angle down. I'm going to go down to the x-axis, and when the x-axis changes color, I'm going to left-click on it. And I'm going to go over a distance to the right and left-click, and then I'm going to stop creating the polyline segment by right-clicking my mouse. That cancels the polyline. And now I'm going to come back up to the right-hand side of that line segment I created earlier. Left-click to create a continuing polyline from that point. I'm going to go up to approximately the same height as the line on the other side, and I'm going to come over a short distance. I'm going to right-click now to stop the polyline, right-click again to clear the tool. I'm going to add some constraints to the shape that I've created. I'm going to go over to the left-hand edge here, and I'm going to constrain its height to 60 millimeters. And the next thing I'm going to do is I'm going to set the vertices on the line segments that are sitting right above our first line that we created. I'm going to make these two lines so that they are horizontally constrained. So if I move one, the other one moves with it. And I'm going to set the length between the top point here and the top left corner of the shape. I'm going to set that to a distance of 80 millimeters. I'm going to take these two line segments here, and I'm going to set them so that they are 23 millimeters high. And I'll just move these constraints around a little bit so that they're easy to see if you're just looking at the video trying to get the same measurements that I have here. And the next thing that I'm going to do is I'm going to set the height of this original line. I'm going to set it to a distance of 47 millimeters from the x-axis. So we'll set that to 47. And I'll move these constraints so they're a little bit easier to see. So there we are. And now we're going to set the length of this right-hand line segment. We're going to set that to a length of 15 millimeters. And we're going to now create a constraint for this end line segment here. And we're going to reference it off this corner right here. That's the right-hand edge of our original line segment that we created. So left-click that corner, left-click the end of that line there, and we're going to set that to a distance of 23 millimeters. And even though our shape is fully constrained, it's not a closed shape. And we're going to add a curve to the front of this shape. So I'm just zooming out a little bit so that I can see the end of the x-axis here. And I'm going to grab the Create Arc by Center tool. And the first thing I'm going to do is I'm going to come down to the x-axis, and when it changes color, I'm going to left-click, and that becomes the center point of the arc I'm creating. And I'm going to go up to this top line segment here that needs to be closed, and I'm going to left click on that. And I'm going to come down and I'm going to left click and I'm using the crosshairs here, so that the crosshairs, the white crosshairs on this tool is my guide. I'm going to left click on the end of that line segment. Now I'm going to right click to clear my tool. So now I have a fully constrained sketch, and I can see that I have a fully enclosed shape as well. So I'm going to close out of the Sketcher workbench now. And I'm going to pad this sketch out 3 millimeters. Now I am going to mirror this shape. And so I'm going to come up here and I'm going to go over to the model panel, make sure I've clicked on the pad so that it is the active shape right now. And I'm going to come up here to mirror. And this dialog is going to ask me how I want to create the mirrored shape. So there are lots of ways of doing this, but here in the left-hand panel are some options. And I'm going to go down here to where it says plane, where it currently says vertical sketch axis. I'm going to click on that, and I'm going to choose select reference. I want to choose the edge of the padded shape that I just created to be the basis of this shape's mirror. So I click on select reference, and now I want to click on this edge. Now, as you can see, the Sketcher XYZ plane references here, these light blue squares are getting in the way. So I'm going to zoom in through them, and I'm going to hover over the edge of that pad there, wait for it to turn light blue, and I'm going to left click on that. And when I do that, here in that left hand panel, we can now see that I have clicked on Phase 5, and when we zoom out and look at it, we can see that the shape has been mirrored across the middle. So I'm happy with this, so I'm going to click close. Now the next thing that we're going to do is we are going to give a radius on these sharp corners over here, and we're going to do that with the fillet tool. So I'm going to zoom in, left click on that first edge, and then I'm going to zoom in on the second edge, hold down Control on the keyboard, and left click on that second edge. So now you can see that I've got these two edges selected, and I'll use the fillet tool, and I'll give it a fillet of 20 millimeters. So now we have the basic shape of the SparkBot robot. And we're going to add a few through holes and slots for the motors, the speed encoder disks, and we're also going to create some slots for the infrared distance sensors that we're going to be using for tracking our line tracking sensors. So to do that, we're going to click on the front or the top face of our base platform now, and we're going to come up here to create sketch. And so the first holes that we're going to add are going to be for the metal brackets that the motors mount onto. And so we need 4 holes. So I'm just going to grab the Create Circle tool, and I'm going to begin by creating just 4 circles approximately in this area. And right click to clear my tool. And now what I'm going to do is I'm going to vertically constrain these first 2 circles to the same vertical plane. I'm going to do the same thing for the second 2 circles. So constrain them to that vertical plane. And now I'm going back up to these top 2 circles, and I'm going to constrain them to the same horizontal plane. I will do the same thing with the bottom 2 circles. So now I have 4 circles, and they will move in relation to each other. We're going to set the size of these circles to all be the same. So I'm just clicking on the outside ring of all 4 of those circles, and I'll click the equal sign. So now all of these circles are equal to each other. And the next thing I'm going to do is I'm going to make it so that these circles, these 2 sides that I've created here, are symmetric around the x-axis. So this is as easy as coming up here and clicking in the center of the top right circle, clicking in the center of the bottom right circle, and clicking on Constrain Symmetric. Now it looks like I didn't click the x-axis. Let's try that again. There we are. So the circles are now constrained around the x-axis. And we're going to set these circles so that they are separated by 8 millimeters. So left click in the center of both circles, and constrain horizontal to 8 millimeters. And we're going to make it so that these circles are separated across the x-axis by 51 millimeters. So left click in the center of the top and bottom circle, and we will constrain vertically to 51 millimeters. Now all that's left is to choose where along the x-axis we want these circles to be locked. And so I'm going to reference the top right corner here, and this effectively is the inside corner of the fender for SparkBot. So using that external geometry reference tool, click on that top line there of the fender, and now I'm going to left click on the inside of this top right circle, left click on the right hand end of that line segment from the geometry reference that we just created, and I'm going to set the distance between those 2 points to 11.5 millimeters. The last thing that we need to do with our 1 degree of freedom is change the size or set the diameter of these circles. So I'm going to set the diameter of these circles to 3 millimeters. So our sketch is fully constrained, and so we can close this sketch, and we'll use the pocket tool to turn those into holes. And so 5 millimeters clears those holes through the shape, so we'll keep them. Now we are using speed sensors to track the rotation of the TT motors in our robot, and the speed encoder discs that go on the end of these double axle motors extends down below the bottom of the base plate for SparkBot. So we've got to create a slot in the base so that these encoder wheels don't rub on the base. And so once again, we will click on the top face of the base plate and we'll create a sketch. And this sketch is going to be symmetric around the y-axis, because the y-axis is the center of the fender area here, and it's also the place where the wheel for SparkBot, or the axle for SparkBot, is located. So the encoder wheel will be symmetric around this y-axis. So we're going to create a couple of rectangles, and once we've got those, we're going to set the length of both rectangles by left clicking on the top edge of both of these rectangles. We're going to set them to be equal. And we're going to do the same thing for the height of these two rectangles. So we'll set them to be equal. And the next thing that we're going to do now is we're going to make it so that these rectangles are symmetric around the y-axis. So come up to the first one, we'll left click on the top left corner, left click on the top right corner, left click on the y-axis, and constrain symmetric. And we'll go to the bottom slot and we'll do the same thing and make it symmetric around the y-axis. Now we're going to set the height of our box, and so we'll set it to 5 millimeters. I'll just pull that out so it's easy to see. And we're going to set the length of the box, and I can either choose to set the length on the top box or the bottom box. It doesn't matter because they're all linked. If I change the bottom, the top will change, etc. So we're going to change the width of this box to be 21 millimeters. And now we're going to make it so that these two boxes are symmetric across the x-axis. And we're going to do that by left clicking on the bottom right corner of the top box, left clicking on the top right corner of the bottom box, and then we're going to click on the x-axis and then come up to constrain symmetric. And now the boxes are symmetric around the x-axis. So now we need to set the distance of these two boxes apart from each other. And I'm going to do that on the other side of the box here. So I'm going to left click on the bottom left corner, left click on the top left corner of the bottom box, and I'm going to set the distance between them to be 34 millimeters. And at this point, our sketch is fully constrained, and so we can close out of it and use the pocket tool to create those slots in the base. Now the last slot that we're going to add is for the infrared distance sensors, which are going to be used to detect the difference between black and white for our line sensor following algorithm. And so we're going to create those two slots up towards the front of the robot. So click on the top face, click on Create Sketch, and we're going to create two rectangles up near the front. And we're going to follow a similar process that we did with the speed encoder slots a moment ago. And so I will set the width of these two boxes to be the same. I will set the height of these two boxes to be the same or equal. And I'm now going to link these two boxes together. So I'm going to click on the bottom right-hand corner of this box, click on the top right corner of the bottom box, and I'm going to constrain these vertically. So if I move one, the other one's going to move. Let's set the width of these boxes. So I'm going to set that to 6.5 millimeters. All right, so now we have both boxes are 6.5 millimeters, and I'm going to set the height of these boxes to 14.5 millimeters. And just like before, I'm going to make these two boxes so that they're symmetric around the x-axis. So left click on the bottom right corner, left click on the top right corner of the bottom box, left click on the x-axis, and constrain symmetric. And so now when I move one box, the other box will move. So the next thing that we're going to do then is we're going to set the distance of these boxes from each other. So I'm going to set the distance between these two boxes to be 24.5 millimeters. And so now we've got 1 degree of freedom, and that 1 degree of freedom is the position of these boxes on the x-axis. And just like last time, I'm going to reference the edge of the fender up here on SparkBot. So I'll use that external geometry reference tool to bring in the edge of the geometry. And I'm going to set it so that our infrared sensor slots are 3 millimeters away from the end of that fender there. So there we are. So we've got a 3 millimeter gap between the end of the fender and the beginning of the infrared sensor socket. All right, so there we are. Our sketch is fully constrained, so we can close it, and we can turn those into pockets as well. Now, if you wanted to continue to add on to this, you could modify this shape. You could add the support frame for the 6-volt battery pack. You could add the speed sensor bracket to this frame, and you could continue to build on it in whatever way that you needed in order to customize your SparkBot. However, if you would like to create a pattern, an SVG pattern that can be sent to the laser cutter, then we need to export this shape as a flattened SVG file. And so we can do that by coming over here to the model panel, left clicking on body, and then we go up to file and we choose export, and we're going to choose flattened SVG from the list. And so give your SVG, that stands for scalable vector graphic, give that a useful name. So I'm just going to call it SparkBot base and save. And now when I come into it, if I would like to modify the shape that I'm going to send to the laser cutter, let's pretend I want to customize this with a name, or I want to add a logo or graphic to the top of it to be engraved by the laser cutter. I can open it in my SVG program. In this case, I'm using Inkscape. And here is here's the platform that we just created. And to create text in Inkscape, you use the text tool. You click into your shape. You need to open up the text and font panel. You can do that by left-clicking on this little drop-down arrow here, and you can find text and font, and that will open this panel here. And then you need to find a font that you find interesting. I'm going to use the Papyrus font here. And I'm just going to write SparkBot. Now my text is white, and that's the reason that I can't see it. So we're going to fix that here in a second by clicking, and we'll come over here to our fill, and our fill is currently set to be fully transparent. So I'm going to set the alpha channel on this all the way to 100%, and so I can now see the color of my text. Spark, gotta click back into it so that I can continue typing. Spark font, there we go. And you move it around, you can change the size back in the text and font panel. You can change the size by choosing the size that you want and clicking apply, so that changes your size. If you would like to rotate the font, you click into it a second time, and the handles on the side of the font will change. So you can click on that handle and rotate it. And now you can left click in the center and move the text around. And that's all there is to it. You can create a graphic. You can add a graphic to the top of your SparkBot platform. Change the name of it from SparkBot to something else. Now, if you're doing text though, the laser cutter, if you're using the Glowforge, the laser cutter needs the text to be converted into a path. Right now, it is still a proper font object. So you do that by making sure that whatever you've written is selected, and you go up to path, and you choose object to path. And when you do that, when you click on the node tool, you'll notice that your font is being converted to a collection of different nodes. And the Glowforge laser cutter will now actually cut your font or engrave your font just the way you have it. Bear in mind, though, that you can't go back after you've converted it and change a spelling error or change the font. You would have to go back into your undo history and return that font back to its editable font object, fix it up, and then you would have to convert it back into a path. So when you've got that all done, you just you save your changes, and when you go to view your file after you've modified it, you should be able to just double click on it and see your logo or whatever text that you've put on it, and the laser cutter will cut this out. So that's about all there is to creating the SparkBot platform. You can either 3D print it by exporting it as an STL, or you can convert it into a flattened SVG file, and you can send it to a laser cutter to be cut out of MDF.